isolation, extraction and their applications. So I request Professor Ladda sir to interact with the student, participant and deliver a talk on the said topic.
Thank you, sir. Good afternoon to everyone. Yeah, post-lunch sessions are difficult, I know. All right. Okay. Once again, good afternoon to everyone. And as the name indicates, I'll be talking about the phytochemicals. Discovery, application, all those parts actually comes much later. And first session actually of, before me, the immediate earlier session was actually on the phytochemicals. And I'm sure actually you got good idea about the phytochemicals. And well, we are very ambitious. We want to do a lot of things. Okay, I mean, it's very nice to talk about the nanoparticle of the phytochemical, but the big question arises, where are the phytochemicals? The major problem is phytochemicals are not readily available. If you look at the cost, actually pretty expensive. Okay, and that is what I will be discussing more with you actually. And I'll be discussing more my journey rather than a theoretical part of it. The kind of phytochemicals which I have started working on it and what are the difficulties which I got it, I'll be more narrating that rather than going actually for the bookish knowledge. Please go ahead. All right. Let me first take you, because most of us are coming from the pharmacy background. And we have a problem with us actually, we are with blinkers. That means we don't see elsewhere. But understand the immense potential of the plant. Every plant has an immense potential, and not necessarily only in pharmacy, because quite a few plants are used extensively in the other field rather than in pharmacy. So when you work in the on the medicinal plant or in general about the plant, I think let's look actually which are the other field where the plants are likely to have their application. So this is what I have just put some photographs which will give an enough idea. I'll start with the alcohol, liquor. Okay, that is the area where a good amount of plant material, I don't know anybody knows about it or not, but we have taught our student actually that cinchona bark, and from cinchona bark you get quinine sulfate or the quinine hydrochloride, and that is having the anti-malarial action. Am I right? This is what has been taught. Anything else has been told about that thereafter, but today it is very clear actually that quinine sulfate or the quinine hydrochloride is no longer used actually as an anti-malarial drug. So when we teach actually entire cinchona, we complete the cinchona, and at the end we say, okay, it contains quinine and the quinidine, and the quinine is having the antimalarial action, and at the end we say, okay, it is no longer used as a drug. So does it make sense to teach actually all this thing, and at the end means we say it is no longer in use? No, it is in use, but it is not in use actually as an antimalarial drug, but it is used actually as a standard beater. Not only standard beater, but it is also used in imparting in the liquor to impart little bitter test. So today cinchona extract and the alkaloid which is obtained from the cinchona is used as bitter to impart in the liquor, alcohol drink, because that needs little bitter taste actually, and that has been attributed, or that has been undertaken actually by incorporating quinine in that. So that is the use of that. I'm just trying to tell you the usage in the other sectors. Then this is the hair dye. Godrej people, they came to me some time back because Godrej is having the hair dye. Hair dye is a big sector. For Godrej, it is 4,000 crore sector. And they were using actually henna leaf. But then when you use henna leaf, the problem is that after applying henna leaf, you have to sit for 2 hours and forcefully watch TV. Am I right? You have to forcefully watch TV for 2 hours actually, because the action takes pretty long time. So they came to me actually whether this can be facilitated. So I said, yes, it is possible actually. If you isolate the constituent which is present in the henna, that is lawson, then probably in case if it is isolated, then probably immediately after applying it will go to the hair, and immediately there will be a chemical reaction taking place and you will get the instant color. And then accordingly we have developed actually 20% lawson content in the hair dye, and now I have developed actually almost up to 95% hair dye that gives instant color. So another application. Neem pesticide, yes. Organic, nowadays I think our pocket is better. Am I right? Our pocket is little better. Pizza, burger. These are the norms now. Okay. And currently everybody is talking about the organic food. Organic food means the one which has not been made use of actually synthetic fertilizer or pesticide for that matter. And neem is perhaps the most widely used organic pesticide, and ultimately which has been used actually for the organic or agricultural produce. Castor oil, again, this is another plant which we teach in our undergraduate, and at the end we say actually it is purgative, but it is no longer used. Again, same problem, that we say, okay, it is a Ricinus communis, because belong to the Euphorbiaceae family, and it has more than 40% oil which contains racinoleic acid, and at the end we say it has a purgative action, but it is no longer used. But still it is extensively cultivated. Castor is perhaps cultivated extensively in Maharashtra, Gujarat and Andhra. What for? It is used actually for making lubricant. There is a company called Castrol. The name itself is derived actually from the castor, because they were in the lubricant actually of the castor seed. So application in the other field. Perfume, another perfume. I don't think you can buy easily 5 ml of sandalwood oil. I'm talking about genuine sandalwood oil. It is very difficult. It is very difficult to have a trustworthy sandalwood oil, and it is very expensive. Currently sandalwood oil actually is in the range of around 70,000 rupees a kg. If you ask me what is the rate of rose oil is, the good rose oil is costing not less than 20 lakh rupees per kg. So look at the application in the other field. Next slide please. All right. Now I'll come to the pharmacy, since I'm going to talk about the phytochemicals and their application in the pharmacy. I'll be talking more about the ashwagandha, because that is actually the known, everybody knows ashwagandha. In fact, the layman also knows ashwagandha, so I think the pharmacy people should be knowing more than that. All right. Many times people ask, why herbal is not progressing well, what is the problem, the herbal medicine doesn't work properly. These are the genuine questions which need to be addressed by the sector, because layman will definitely ask this kind of question actually, why Ayurvedic drugs are not working. Now the simple reason why Ayurvedic drugs are not working, because in Ayurveda, ashwagandha dose is given 20 grams per day. Now it is very difficult to accommodate that 20 grams, all the goodness which is present in the 20 grams in 2 capsules. Very difficult, unless you have a good technology to have all the constituents which are present in the 20 grams to get accommodated in the two capsules. Till such time, I don't think the Ayurvedic medicine will work. So patent and proprietary Ayurvedic medicine is definitely needs much more actually attention in terms of the research than what it is current status is all about. Now the complexity of Ayurvedic product is like this. Now ashwagandha is available in the various forms. Ashwagandha root, microscopy plays a role in identification. Ashwagandha churna, yes, it is simple powder actually of the ashwagandha churna. Then we have a ashwagandha rishta, which is actually an alcohol, self-generated alcohol preparation as per Ayurveda. I must tell you at this moment actually, now we have today we are talking about the traditional Indian science, and now this is the topic which is being incorporated actually even at the graduate level, professional graduate level. And this is a very classical example of the Ayurveda. Today we have those who are in pharmacy and pharmacognosy. In lab actually, perhaps you will be having at least 7 to 10 solvents, right from to actually water, then we have methanol, ethanol, acetone, ethyl acetate, thereafter we have IPA, isopropyl alcohol, then we have chloroform, dichloromethane, benzene, toluene, petroleum ether, hexane. Those are the different solvents which one make use of it. Ayurveda never had all these solvents with them, but in spite of that also, they meticulously manage the constituent which are present in the plant and getting it extracted. They have used only 3 solvents. One is water, kadha. So wherever water-soluble constituents are there, they have recommended only in the form of the kadha. Now ashwagandha, today we know actually it contains steroid. Ayurvedic people were not knowing that it contains steroids. But what they were knowing it actually, that it contains some constituents which are not soluble in water. And that is why they have never recommended kadha of ashwagandha. Ashwagandha is always recommended either in the churna form, so that your gut can absorb whatever it is present in that, or in the form of the ashwagandha rishta, which has alcohol in it. Steroids are soluble in alcohol. And wherever you have a non-polar constituent, they have recommended in the form of the taila. So look at this, what Ayurveda has done. Ayurveda used only 3 solvents, water, alcohol and taila, polar, semi-polar and non-polar. So that is how it has been managed. Anyway, coming back. So ashwagandha rishta, then we have ashwagandha rishta do not have any cellular structure. It's only a liquid. So at the most you can analyze ashwagandha, which is in the form of the bisanolide or the vitaferin or alcohol content in that. Thereafter ashwagandha extract standardized. Now we have, initially we exported good amount of ashwagandha extract, but soon foreigners have realized actually that ashwagandha extract, what they are getting it actually is only starch. So they started insisting actually that now whatever the ashwagandha extract which we will buy, that should be standardized for certain chemical constituent, and bisanolide and vitaferin, these are the major constituents which are present in the ashwagandha. Then came the bisanolide. So today they are asking for 5% bisanolide. Some people are asking even 10% bisanolide, because now it has been observed actually these are the ones which are therapeutically important. Then vitaferin is now available for the analytical purpose, because how to judge quality of a ashwagandha? Because you have no means. Either you should have the entire, now the agriculture pressure is so much actually on the agriculture is that earlier ashwagandha was obtained after 18 months of the planting. But today there was so much of pressure, they are uprooting the plant actually after 6 to 8 months. The quality is becoming poor because it does not have the requisite content of the bisanolide in that. So that is the major problem, and that is why vitaferin is available, so that at least you can analyze what is the vitaferin content in the extract. And then of course we have ashwagandha tablet, capsule. I'm sorry, I'm an academic person, so I will be speaking very frank. Most of these products actually are useless because they do not have the requisite potency of the constituent in them, and unfortunately Ayurvedic industry at this moment is not talking about the phytochemicals. They are not analyzing, most of the analysis is very trivial, ash value, extractive value, pH and solubility, that is the only COA they generated actually, and that does not speak about the efficacy or about the constituents which are present in the plant. Next slide please. I will skip this slide. This is metabolite, primary metabolite and the secondary metabolite, which by and large people know. Next slide please. Okay, since I'll be talking about the phytochemicals actually and the difficulty associated with that, and why further research cannot be possible unless they are made available. So my entire emphasis is actually how to make available these phytochemicals in affordable cost. There are the various names by which they are normally available in the market. Some people call it phytochemical, phytoconstituent, some call it secondary metabolite, some people may call it bioactive compound. Everybody is looking from the different angle. If there's an analytical chemist, he will say for me it's analyte. That's it. Okay? So everybody is looking from the different angle, biomarkers, markers. So there are the various terms which are in use depending upon your application part of it. Next slide please. Next slide. All right. Now when we talk about the phytochemicals, what is the requirement? Number one, phytochemicals is a compound reported to be present in the plant whose identity and purity has been confirmed. If you refer Merck index, most of the phytoconstituents are reported in that. So this is what the most important requirement actually. Now when we talk about the analytical part of it, that means if I have to undertake analysis, I have seen many papers actually where students have used actually beta-cytosterol and the stigmasterol as a marker compound for the analysis. Those are useless compounds for the analysis because practically every plant contains those compounds. When you undertake any analysis, in analysis that uniqueness of that plant must be established. That means that plant is known actually whether that plant contains that unique compound, and only that unique compound should be taken. For example, in case of ashwagandha, vitaferin is present only in ashwagandha, no other plant contains vitaferin. So vitaferin is the right marker actually to judge the quality of ashwagandha root. All right. So analytical purpose, it may be one of the unique or important compound. That is what one must make use of that actually. Compound present in the herb, it may or may not be active compound. See, your requirement is different. From the therapeutic angle, requirement is different because there it should have the medicinal action. But when you talk about the quality, definitely you should be able to judge the quality and establish the quality. For that you need some marker. Okay? And for that it need not be active. For example, if a Triphala churna is there, it contains tannin. But all the three fruit contains tannin. So tannin may be biologically important, but tannin from the analytical angle is not possible to use that actually for the analytical purpose. So you may have to choose some different marker to establish whether it is Harda, Behada or Amla. Okay, understand that requirement. Okay, another important requirement, it can be isolated from plant or it can be made synthetically. Many students, they get actually emotionally attached. Please do not do that. Don't try to isolate quercetin from a plant. Don't try to isolate because quercetin is present in very low quantity. Quercetin can be converted in simple one single step from rutin, which is extensively available in the plant called ruta graveolens. Okay? So there is no point actually in isolating quercetin from a plant where it is present in very low concentration. All right. I have given another example. I think I have already talked about beta cytosine and the cytosterol, because those are very difficult to very difficult to separate. So if you want to separate, or if you want to have cytosterol, beta cytosterol or sigma sterol, look for a plant which is rich in that, rather than trying to separate, because those are different. These two compounds are differing only by one single double bond. So it is very difficult, practically impossible to separate from a mixture. Next slide, please. All right, let me just take you through the journey of some of the plant material which are important. This, of course, you know, like atropine from the belladonna. How many of you know atropine is obtained from which plant for the commerce? An answer would be belladonna, and that is the wrong answer. Okay, atropine is obtained from an Australian plant called Duboisia. That is the plant which has been used actually for the commercial production. Digoxin, still obtained from the plant. Etoposide is semisynthetic, which is converted from the podophyllatoxin to etoposide. Silabin perhaps is the most important molecule, because as on today there is no other molecule which is with the proven hepatoprotective activity. And today if anybody wants to synthesize any compound which is hepatoprotective, they need to compare their activity against silabin or silamarine. Silamarine is a mixture, silabin is an individual constituent. Morphine, problematic compound obtained from a plant. Currently I am involved actually with this project of extraction, the isolation of the morphine. Many of you will not have a chance even to look at the morphine. Right now I am extracting, and I am using morphine every day practically for the extraction purpose and analytical purpose. I am extracting for the first time in the country from poppy straw. Poppy straw refers to the fruit part of it, which contains close to 0.5% morphine, which all this year government was burning it actually. After removing the khaskhas, whatever the poppy straw which has been left behind, that was being burned because it was a narcotic. Today we have developed a method indigenously, and we are isolating morphine, which has been used actually as an analgesic, or it is converted to a codeine, which has been used actually as an anti-tissue or the cough suppressant. Carbinoxolone is another natural molecule. Carbinoxolone is a semisynthetic which is obtained from the 18-beta-glycyrrhetinic acid, which is from the Glycyrrhiza glabra. So this is antacid. Reserpine is actually a hypotensive drug, and there's a product actually, serpine, or there's a product, a combination actually, diuretic and of course hypotensive drug. Okay. Where the reserpine is used, reserpine is obtained from two plants. One is the Indian plant called Rauwolfia serpentina, from the root part of it, and then there is another African plant called Rauwolfia vomitoria, the bark of which contains reserpine. But reserpine India is exporting actually, so we have a good cultivation of Rauwolfia as well as extraction isolation. THC and CBD, today it has been talked about a lot, and many companies have started working on the CBD. CBD is CBD is a cannabidiol, and THC is tetrahydrocannabinol. Tetrahydrocannabinol is a problematic agent because it causes hallucination, but CBD is free from that. And CBD currently is perceived to be a good actually for the health, and currently it is extensively used actually as a nutraceutical product. Taxol, I think earlier speaker said about the Taxol, anti-cancer drug which is obtained from the Taxus brevifolia, but currently it is obtained actually from a plant called Taxus baccata, Himalayan yew, and it is converted to, from that you get actually 10-deacetyl baccatin, and that is converted actually to a Taxol by the semisynthetic process. Next slide please. Well, these are the phytochemicals which are used as a functional food. Earlier was a drug, these are the functional food. Curcuminoid is not considered to be a drug, it is still considered to be a functional food or a nutraceutical product. Ellagic acid obtained from the pomegranate, and Chebulic myrobalan, again nutraceutical. Forskolin from Coleus forskolai, anti-obesity agent, but again nutraceutical, no longer drug, because they do not have action with surety. That is why they are still into the nutraceutical field. They have a beneficial effect, but not medicinal effect. Piperine, another beauty of Ayurveda is that practically every Ayurvedic formulation, I am talking about the generic formulation of the Ayurveda, you will find either black pepper or long pepper being present in that. Any formulation you take it, and today we came to know that piperine is having the property that it enhances the bioavailability of otherwise poorly bioavailable drug. And that is what the purpose, what it is serving in the Ayurvedic product. Lycopene is from tomato, which is an antioxidant and good for the eyes. Hydroxycitric acid, another important plant material which is growing in the coastal belt actually, west coast of the India, Garcinia cambogia, and that is having the anti-obesity action. Soya isoflavone, again it's a good finding actually from one region of the country actually, that the cancer instances in the women were less actually those who were consuming soya. And ultimately, when it was investigated, it was found actually that the soya isoflavone, they are estrogenic. Both the isoflavone, genistein and the diazerin, actually, they are estrogenic. And today, they have been targeted actually as a estrogenic in the nutraceutical. Next slide, please. These are the food sector. Now, phytochemicals or the plant material which are used in the food sector besides starch. Starch is of course extensively used. Annatto, Amul butter is colored actually. All the commercial butters are colored yellow by annatto. Otherwise, at home you get white butter, but commercial butters are yellow in color, and that is because of the incorporation of the annatto in that. Vanillin, perhaps the most widely used flavor of the world. You take any ice cream and the base flavor is vanillin, and then add-on is there butterscotch or whatever other flavors which are there, but base flavor is vanillin. And startling fact is that only 1% of the vanillin which has been used, entire vanillin which has been used, only 1% comes from the natural. 99% comes actually from the synthetic. Okay? But yes, natural vanilla is very, very expensive. The pod itself is around 40,000 rupees a kg, so you cannot imagine about the flavor part of it. Gallic acid and the gallate. Gallic acid is still obtained actually from a plant source, from galls. And gallic acid has been converted actually to the gallate, and gallates are used in the food sector actually as an antioxidant, preservative. Stevia glycoside, those who are diabetic, I am sure they must have tried this. And they are almost 200 times more sweeter than water, than sugar, and today they are extensively been used as a sweetener. Today stevia glycosides are also used in a sweet meat, mithai. Thumatin, I am sure quite a few must have heard this name for the first time. It is obtained from a plant called Thumatococcus daniel, African plant, and this is the protein, and which is almost 1,500 times more sweeter than sugar. Okay, a protein which is 1,500 times more sweeter than sugar, but only problem being a protein, you cannot use it in a hot beverage. You can use at the most in ice cream or the cold beverages, but not in a hot beverages, because being a protein, it will get denatured if it is heated more than 60 degrees. Glycyrrhizin, permitted sweetener as per the FDA. So these are some of the constituents which are used in the food sector. Next slide please. All right. Morning, almost 39% of the drugs which are used actually are filed in the US are from the natural origin. And I will make a statement here actually, almost 80% of the APIs today which are used, APIs, 80%, they have a direct or the indirect bearing of natural product. Okay, direct or the indirect. Which is the drug which is most extensively used actually for diabetes? Metformin? Answer is metformin. Okay? Metformin itself has been synthesized actually by looking at the structure of galligine. Galligine is obtained from a plant called Galliga officinalis. Next slide. All right. Okay, this is since I think I should have asked this question first. What is your aim? All the students, what is the aim? Aim is very simple. Correct, no? This is the aim. And this is the slide actually which can fulfill your aim. If you look at, these are all the Indian plants. Look at the irony of this. These are all the questions. I have given actually some example. Beta-myrin is present in a Ficus elastica plant, that is called the rubber plant. Okay? The price as per the sigma is 64,000 rupees for 10 milligram. Arjunic acid is present in the Arjuna, again Indian plant. Arjunic acid is 1,33,000 rupees for 10 milligram. Just imagine if you are possessing 1 gram of this. Gymnema genin from the Gymnema sylvester, again Indian plant which is used in diabetes, that contains gymnemic acid or Gymnema genin after hydrolysis. It can fetch you actually 77,000 rupees for 10 milligram. Shatawarin, another Indian plant, very expensive. Shatawarin 4 is very expensive, 77,000 rupees for 10 milligram. Vasicin, a cup suppressant. Adatoda vesica or the adulsa is a cup suppressant actually, and vasicin which has been isolated from that as per sigma is very expensive. Okay, 47,000 rupees for 20 milligram. And vitaferin A which is obtained from the ashwagandha is 59,000 rupees for 5 milligrams. So these are the rates actually if you have to buy this constituent from Sigma or any other overseas company. And this also indicates the potential in the field. If you isolate, extract and isolate any of this phytochemical, and not necessarily in 100% purity, even if the 95% purity, I can tell you, you can get more, I mean, whatever the rates are there, actually, you can get at least 50% of the rate for sure. So this is the scope actually of the subject. Next slide, please. All right, I was just talking about the metformin. So this is the plant actually, which has been used actually, the constituent of which has been utilized actually for getting the idea of making the metformin. So this is Gallica officinalis and French. This is a plant actually of the France origin. And there it was considered to be a toxic because it was causing hypoglycemia. And what is required in the diabetes is precisely the same action, hypoglycemia, because you are hyperglycemic. So what you need is a hypoglycemia. So Gallica officinalis contains two constituents called galligine and synthallin A. Galligine is of course guanidine derivative, and then synthallin is digonidine, whereas metformin is the bigonide. Okay? So the idea of the metformin came actually by looking at the structure of guanidine. So all the anti-diabetic drug, of this series, whether it is metformin, butformin, or the ferformin, the origin lies actually in a plant called Gallica officinalis and of course galligine. Next slide, please. Next slide. Okay, another plant. During COVID, I think India has made good profit. Indian pharmaceutical company has made good profit out of manufacturing of the chloroquine sulfate or chloroquine phosphate. Many companies have made profit actually because we have supplied to almost 52 countries chloroquine phosphate. And I must thank then of course President Trump, because he uttered one day actually that the chloroquine is useful, and we are Indian company have made good profit. Ultimately it came out to be a useless compound. Okay, but yes, we have made good amount of profit from that. If you look at this compound, look at the structure very carefully. Those who are from the background, look at the structure very carefully. Quinine, first structure is the quinine. This is the quinine structure, first one, and then of course we have actually quinaquine, chloroquine, hydroxychloroquine, amodiaquine, primaquine, mefloquine. These are all the constituents which have been, so these are all synthetic analogues. And if you look at the structure of the synthetic analogues, all of them, they have retained the quinoline ring in them, or the quinoline ring, and quinacridine ring also in some or the other form. So by looking at the structure of the quinine, all these synthetic analogues were possible to design. If the quinine structure would not have been made available, I don't think all these synthetic analogues would have been available in the market today. Next slide, please. Another plant material, diazoxanine. Today we have dexamethasone, betamethasone. I don't think it is possible to have it without either diazoxanine or hecogenine or solazodine. These are the three steroids which are naturally obtained, and thereafter they are converted into a 16-DPA, that is 16-dihydropregnenolone acetate, and that is thereafter converted actually into a dexamethasone or the betamethasone. So I don't think complicated steroid molecule can be obtained in commercial feasible way by synthetic route. It has to be obtained by the semi-synthetic route only, and that route is actually from the diazoxanine. In plant it is present in the form of the diosine. Diosine is converted to a diazoxanine. Diazoxanine is converted to a 16-DPA, that is 16-dihydropregnenolone acetate, and that has been used actually as a starting material for most of the semi-synthetic steroids, which includes betamethasone, dexamethasone, and the hydrocortisone. Next slide, please. All right, I think this is the slide where youngsters should not get into this. These are all problematic drug: amphetamine, methamphetamine, methcathinone, mephedrone, esketamine, that is methylene dioxide methamphetamine, and methylene dioxide methcathinone. Now these are the compounds which are available in the illegal way. I must tell you, in case if you possess any of this molecule, you will be in a difficult situation, because these are all narcotics. Okay, but and whatever, whether we like it or not, but they are there in the market. Okay, in the illegal way, they are there in the market. Okay, and the origin of that, all these molecule lies from these two molecule actually. One cathinone from an African plant called Catha edulis, and the other one is ephedrine from the Ephedra seneca. So all those molecules which are problematic and which are extensively used today, whether it is party drug or whether it is amphetamine, their origin lies actually in these two plants, Catha edulis, cathinone, and ephedrine from Ephedra plant. Next slide, please. Okay. Most of the cases which I have earlier presented actually, those were having the similar kind of the action after derivatization. Now here is the slide. If you look at the barbaloin, which is present in the aloe, that is having the purgative action. Okay. but then it have to convert it to aloimodine. So now on the right side you can see the aloimodine. Aloimodine is then converted to the rhine. So this is actually the third is the rhine on the right side. And rhine, after diacetylation, is converted into a diacetyl-rhine. That is called the diaserine. Diaserine is having the anti-arthritic action. So the original molecule is having the purgative action, but the modified molecule having the altogether different action called the anti-arthritic action. And today diaserine is an API. And there is no other route to manufacture diaserine but to obtain only from the barbaline route only. Okay, so you have to convert barbaline to aloimodine, aloimodine to rhine, and rhine to diaserine. Next slide, please. Another plant material, and I am sure all of you are using some or the other mosquito repellent at home. Mosquito is a major problem in the tropical, and we are using either All Out or Good Night, some or the other. I don't know how many of you know what it contains, but those products contains two important constituents. One is alethrin, and second is the transfluethrin. And if you look at the structure of the alethrin, the transfluethrin, and on the left side, I have put the natural molecule called pyrethroids, and circled actually in a red. So look at all the synthetic molecule, either transfluethrin or alethrin or cypermethrin. This is cypermethrin, which is used extensively in the agriculture. So in all this molecule, the feature which is essential as a pesticide is been maintained. So all these pesticides were made available only by looking at the natural molecule called pyrethroids. If the pyrethroid structure would not have been put forward, scientists would have taken many years actually to come out with the effective insecticide. Next slide. All right, so those were I was just trying to give you the influence of the plant material on synthetic analogs. Phytochemicals in the herbal drug analysis. Next slide, please. Next slide. Okay. Now, I am sincerely requesting all the Ayurvedic company to at least establish the dose of Vasicin in cup syrup. Because cup syrup is one sector where Ayurveda is doing extremely well, because everybody, whenever the winter comes, people uses Ayurvedic cup syrup, which is by and large comprising of Vasaka. Okay, Adulsa or Vasaka. And there are four main drugs which are normally being put into that. One is Adulsa, second one is Tulsi, third one is Glycyrrhiza, and the fourth one is a Kantakari, Soranam Xanthocarpum. Okay, so they are the four plant materials which have been pushed. I have been requesting all the Ayurvedic industry to at least standardize and establish the exact dose of this plant material, most important. But it is not possible unless the Vasicin is made available. And many times I have come across actually the product does not contain Vasicin, so definitely it will not be able to give you any effect, as simple. So what we need to do actually, if we are, in order to ensure the medicine, herbal medicine, we need to have a marker compound, and on the basis of that, we must establish actually the dose of that marker compound for a therapeutic purpose. Unless we establish that, till such time, I think there will be a lot of variation, and that inconsistency of biological action will prevail there. Next slide, please. All right. This was one challenge which was given to me by one Singapore-based company. They had a 9-herb product, and they have one capsule, and they told me actually, sir, please prove that our product contains all the 9 herbs in them, and whether they contain in the same proportion by which they mention on the label. That means if the astragalus root is there, they have mentioned it contains 600 milligram per capsule. So it was a challenge to us actually. So what we did, we took up one phytochemical each from each herb actually, preferably the marker compound, and we first established by way of TLC. Next slide, please. Next slide. Yeah, we first established the presence of that phytochemical by the TLC, thin layer chromatography. So all 8 track what you see actually, those were the 8 products. What they used to have they used to have the biological model, and they used to subject every batch to the biological model. And only when the biological model used to pass, they used to release the batch. And invariably what used to happen actually, out of 3 batches, 2 used to fail and only 1 used to pass. And it was a huge loss to the company. So then they told me actually find out how to do this. What we did actually, we took all the biologically passed batches, and we found out the content of this phytochemical in them, and we gave them the window part of it. Okay, now it should have in this window, then only the product will be working. And that is what precisely we did. So initially it was proved actually physical presence, that particular compound is present, that means that particular herb is represented, and same thing is thereafter quantified with the help of a HPLC. And thereafter we have given them the window that okay, now astragaloside which is present from the astragalus root should be in this concentration, then only your biological action is likely to get released or the cleared actually, and that is what precisely happened. And once we gave the actually, they started getting all those things into that range, and now they do not have this problem of 2 batches failing after every 3 batches. Next slide, please. All right, this was one patent which was filed actually, and it was granted US patent, and it was simple question which came to for the query. We have used 3 solvent. It was a combination of the 4 herbs, and we have used 3 solvent, combination of the solvent. One was alcohol, second was water, and third was alcohol, combination. So the question came actually, why do you need this combination? Then we proved by this simple TLC that yes, these are the 4 tracks. First track is of a marker compound. So in first case it is amygdalin, in second case it is hydroxysulfur yellow, and in third case it is beta-azarone. So they represent the 3 drugs. So amygdalin being a glycoside is soluble in alcohol, and you can see the first track is of a ethanol, second track is the ethanol and the water, and the second track is only of ethanol, third track is combination of ethanol and the water, and the fourth track is only of the water. So if you see the amygdalin, the content in the alcohol is more, but in alcohol and water also is better, but in water it is less, because it is less soluble in water. In case of hydroxysafflower yellow, it is more in the water, which is present because it's a water soluble dye, but in alcohol it is not present, but in combination of the water and alcohol it is present. And in case of the third, that is beta-azarone, it is present in the alcohol, but water do not show the presence. And that is how we proved actually the combination of these 2 solvent is required to represent all the 3 major constituents which are present in the 3 herbs. Next slide, please. All right, I will just take you through some case studies and the difficulties what we have encountered. These are the phytochemicals of which we have developed the methods in the lab, and now they are commercialized. Next. All right, caffeine. I must tell you right now, I have executed one project in the company actually. Nestle is making decaffeinated coffee. So whatever decaffeinated thing what they have, it is junk for them. And that was containing 50% caffeine in them. And I have took that 50% caffeine and converted into a 95% caffeine, and today it is being sold actually as a natural caffeine for the nutraceutical purpose. So this is from the waste part of it. Because decaffeinated coffee, it was a waste for the Nestle that was taken up, and it was used actually for generating nutraceutical. Next. I will skip this. Next. Embellin, Embellia officinalis, Embellia geriumcotam and the Embellia rives, they are the 2 plants actually, from where you get the embellin. Embellin is benzoquinone. Okay, and we have generated today, my company is the only company which is selling this embellin in the market. Okay, there is no other company which is selling embellin. Okay, and the price at which it is being sold actually is 2,000 rupees a gram. From 1 kg you get around 15 gram. The 1 kg of the raw material costs only 700 rupees. The extraction cost is around 1,000 rupees. So in 2,000 rupees, I am getting actually maybe 15 gram. So this is the price which is available, and this is the scope which is available in the subject. Next slide, please. All right, this is the raw material, and this is the finished product, that is crystals of embellin. Next. Black pepper, piperine. Next. Okay, these are the piperine crystals. Okay, they are the piperine crystals actually, and this has been extracted by the PET ether. Normally, most of the reported method you will find actually they will recommend you extract with alcohol. Yes, you can do that actually. We have done with the PET ether in which it is insoluble, just to prove that yes, though it is insoluble, but still it gets extracted. So many times what happens in case of extraction, you have to be very careful. What you want is only 1%, but what you don't want from the plant material is almost 99%. So you have to be very careful in thinking about setting the extraction process. So I'm just trying to show you different extraction processes. Here we have used the solvent in which piperine is insoluble. So we have used PET ether in which piperine is insoluble, but still when we extract with the PET ether, piperine comes along with that because the fruit contains oil. In oil, piperine is soluble, so the piperine comes along with the oil, and when we concentrate, the oil remains into the PET ether, whereas piperine being less soluble, it has been thrown out in the form of the precipitate. Next slide, please. And thereafter it has been crystallized. Next slide, please. Ellagic acid. Ellagic acid as such is not present actually in a handsome concentration in Harda. That is actually a Terminalia chibula. It is not present in a good concentration. It is present but very meager concentration. But if you want a high concentration, the terminal tubula contains actually ellagic tannin. So ellagic tannin on hydrolysis gives ellagic acid, and that can be obtained almost to the extent of around 3 to 4%. Okay, but then there is a problem actually. Ellagic acid, most of us, we normally believe, those who are doing the extraction, we normally heat the material. That means whichever solvent we take it, we normally heat it 40 to 45 degree, or maybe sometimes 60 degree we heat it. But in this particular case, if you heat it, because we have used, this contains tannin, so tannin can be easily extracted actually by either water or alcohol. Alcohol is expensive affair, water is cheaper affair. Okay, so we also extract it with water. But if you use heat in this case, since the fruit also contains starch in that, if you use heat, starch will get gelatinized, and thereafter filtration will be a major problem. So you cannot afford to use heat actually for the extraction. You have to use cold extraction and then subject it actually for the hydrolysis. Otherwise, you will get a lot of starch will get gelatinized, and thereafter filtration will not be possible, and you will not be able to proceed further. Next slide, please. This is the ellagic acid, which can be crystallized, actually recrystallized by the pyridine. Next. Lawson, I think I have already narrated you. I will not be able to reveal the exact method how we have done that, but some schematic diagram. Next slide, please. So this is a schematic. You can read actually how we have done. Exact details I will not give, but we have treated with alkali. Major problem of the henna is that henna contains huge amount of mucilage in that. And mucilage, and you have no other option because you have to extract with the water. No other option, because if you use methanol, again the problem arises actually, and you don't get the good yield. The reason, because the dye is not present in a free form, it is present in the glycoside form. So it is not possible to extract in any other solvent other than water. You have to use water. But then when you use water, mucilage is a major problem, and you have to deal with the filtration issue. Next slide, please. Kaolin, I don't know how many of you know, it's called the khela. Khela is a plant, khela is a name which has been used internationally, and it is Ammi Visnaga, from where you get the kaolin. Kaolin is a furanochromine, and it is again used, it was used actually as a nutraceutical product. Today, of course, it is not much used actually, because it is confined to only Mediterranean region. It is not available freely elsewhere. Next. So this was a kaolin which was isolated. It was, we have done this extraction isolation for ICMR, because I was doing the monograph of the ICMR, and there they have asked me to make the monograph on the khela itself, and we were not having the kaolin, so we isolated, and this was the procedure which was adopted for the isolation, and we could get kaolin isolated from that, and that was used actually for the ICMR generating the monograph. Next slide, please. This is the chromatogram of isolated. Top one is the mixture, that means the extract, and the isolated one is the lower one. You can see the single peak of the HPLC. Next. And we published the method thereafter, which was taken up by the wiki. So wiki, it has been acknowledged actually that this is the method which has been, so wiki has acknowledged us. Next. All right, mangiferin. It's very unfortunate actually that we have so much of, practically every state has a mango. Am I right? Every state in India has a mango cultivation, but in spite of that also we are importing mangiferin. We are importing mangiferin, and mangiferin is the sole source, mango is the sole source of mangiferin. And we do not have here any industry which is generating mangiferin here, and today mangiferin is extensively used in nutraceutical as an antioxidant. Okay, it's a xanthone derivative, and mangiferin is present in the inner bark of mango, inner bark. Okay, so one has to be very careful. You need not sacrifice the tree. I know mango is an important tree, but you need not sacrifice tree. What you can do, you can obtain it from the branches, because branches also have a bark, and the inner bark of that can be used actually for obtaining mangiferin. Next slide. This is about the mangiferin inner bark that contains, when you peel it off, you will be able to see some yellowish residue, and that is nothing but the crude mangiferin, which can be isolated, and thereafter it can be purified. This is all the data confirming the identity and the purity part of it. Next. Same mangiferin. Next. All right. This is barbaloin. We have converted, actually developed technology. Next slide, please. Converted. This is the technology which was converted and passed on to the industry for the manufacture. We have generated only technology up to the aloe-imodine, because latter part requires acetic anhydride. So acetic anhydride is the problem. I know. I don't know how to, whether you have acetic anhydride here, because acetic anhydride is not possible to get it so easily. Okay, because it has been misused actually for converting morphine into a heroin. So we have generated technology in situ, that means without separating barbaloin, converted to aloe-imodine, and aloe-imodine thereafter it has been extracted actually by the toluene as a solvent to get only aloe-imodine. Next. Okay, ursolic acid, another important plant material which is present on the apple skin. Apple skin is glossy because of the presence of the ursolic acid. So is the case with the periwinkle, Vinca rosea. Vinca rosea leaves are also very glossy. And that is once again because of the presence of the ursolic acid on the surface part of it. I don't know how many of you know, but earlier ancient Indian writing is on which paper? Ancient Indian writing is on which paper? It is on a paper, it is on a bark rather, not paper, but that looks like a paper. It is on a bark of Betula utilis, it is called the birch bark. Okay? And that birch bark contains another triterpenoid like ursolic acid that contains betulin. It is called the Betula utilis. And that particular bark, it separates in the form of the thin film, and that was used actually as a paper. And why it remained good? It remained good because it was containing the high percentage of the betulin. And betulin remains unaffected by all the weather changes and all that. Okay, betulin is a very close relative of ursolic acid. So as I told you, ursolic acid is present on in a periwinkle leaf. It is present in apple skin. It is also present in tulsi. And the picture which has been shown actually, that is Nerium oleander, that is Kaner in Marathi, and the leaf of which contains almost 4%. But the problem of this particular plant is that this plant is considered to be a toxic in Ayurveda, particularly the root part of it. Root part is the toxic because it contains some cardiac glycoside of the cardinolite type. But this project I have worked actually because some people were exporting tulsi extract, and their overseas buyer were insisting that tulsi extract must have 1% ursolic acid in that. And no way they were getting it actually because they were doing the water extract. If you look at the compound, this is not water soluble compound. This is water insoluble compound, so you cannot get it in a water soluble extract. So you have no other option but to spike it. I am sorry, this is unethical but true. And these are some commercial things actually which you must learn at the early stage. So this was the project which was undertaken actually to spike ursolic acid in tulsi extract. Anyway, today ursolic acid is pretty expensive, and currently this is in the range of around 70 to 80,000 rupees a kg, around 90%. Next slide please. Well, we have developed the method for the isolation of the ursolic acid from Nerium oleander to the extent of around 2%. It contains 4%, but then obtainable yield is around 2%. Next slide please. Alright, that is all about ursolic acid only. Next. Forskolin, another plant material which has been extracted and isolated in India, and there is a good demand for this particular plant material because it has an anti-obesity action. And one company has made a good fortune out of it from the Bangalore called Sabinsa Corporation, and they have made this, and they had a patent actually for the anti-obesity action. In fact, very interesting plant actually. This plant was extensively worked by the multinational in 1985. In 1985 in Bombay, Hex company was there, and those days the Hex company has worked on 1,500 plants. Out of that, 4 plants came out to be promising, and out of that 4 plants, 1 plant was Coleus forskolii. And initially their work was on the heart. So they were working on the heart, and it was found to be beneficial actually, but then the concentration at which it was to be used actually, that was too high, and it was leading to the toxicity. So being a multinational, they have dumped this molecule. That means they have spent huge amount of money, extracted, isolated, did a lot of biological action, but eventually they have dumped this molecule saying that it is toxic. So they have dumped this molecule. Another Indian company, they looked at this molecule, and one action which was reported in the media was that it acts on adenylate cyclase enzyme, which in turn improves the CMP level in the body. So this was the report which was published actually, and this fellow has looked at this property that it acts on the adenylate cyclase enzyme, which in turn improves the CMP level in the body. And he connected to the obesity because in obesity, CMP level goes down. So he found, okay, the CMP level are going up, that means it will have the anti-obesity action. And accordingly, he started working on that, and he ultimately has proved that it has an anti-obesity action. He filed a patent, and for 10 years, he made fortune out of it. Next slide, please. So this is a compound called forskolin. It was also called coleonol or colforsin. These are the different names actually. And this is the diterpene compound which is having anti-obesity action. Currently, it is also been pursued actually as for intraocular pressure. Okay. Next slide, please. Okay, this is about the action that it acts on a adenylate cyclase enzyme, which in turn acts on the cyclic AMP, and cyclic AMP is mediator for many of these things, so it is having the wide application. Next slide, please. Another plant, Karanjin. I think this area is by and large actually agricultural area, and all agriculturalists today they are using Karanja as a pesticide. Okay, Karanja oil is used as a pesticide, and Karanja pesticide is quite common in the market. And what is pesticide in that actually is the Karanjin. The compound which is being shown here is the Karanjin is the pesticide in that. Okay, rest of the oil is triglyceride, so it cannot be pesticide. The only thing what is having the pesticidal action is Karanjin, that is furanocoumarin. Okay, and furanocoumarins are less soluble in oil, and that is why Pongamia oil, that is called the Pongam oil. Pongam oil is not much used actually because it is not edible, and that is why a lot of work has been undertaken actually as a biofuel also. Well, biofuel has not worked out because it's too expensive, but extensively it has been used in the pesticide, and it is actually I don't know what kind of pesticide it is, but it's the property of it is like this: it absorbs the UV. So normally this is used in the form of the foliar spray. So when it has been exposed to the sun, this compound they absorb the UV and make the insect restless. That is how the insect get killed. So the compound which is eventually responsible for pesticide action is Karanjin. Next slide, please. All right, that is about the extraction isolation of the Karanjin. Next. Okay, another important compound. 20-hydroxyigdazone, very important compound. I have shown the snake actually which is shedding the skin, and snake cannot grow unless it sheds the skin. It is very simple. Okay, and likewise, next slide. Okay, this is the important application of the igdazone. This project has come actually for the silk industry. Silk industry, because the growth of the silk insect depends upon the hormone called igdazone. In natural course, this particular hormone is obtained from a mulberry leaves, tuti. In Marathi it is called tuti. And the igdazone is present in the mulberry leaf on which the silk insect feeds. But unfortunately what happened, the development of the insect takes place very ununiformly. And with the result, small farmers, they face tremendous problem actually, because they have to go to their market with their produce practically every day. To solve this problem actually, so that uniform development takes place, the company came with the idea, why not we spike actually with a igdazone, so that there will be a uniform development of the insect will take place. And accordingly, we have generated igdazone for them. This is the life cycle of the silk insect. It is egg, larva, egg, larva, pupa, and then chrysalis. This is the lifestyle. Now, important feature of this actually, the pupal stage. Pupal stage involves 5 instars, and each instar lasts actually from the 2 to 3 weeks. And every instar, it has to shed the skin. Unless it shreds the skin, it cannot grow in size. And the shedding the skin phenomena is controlled actually by the igdazone. And that is why igdazone is very important actually in the life cycle of silk insect. Next slide, please. So what we have done actually, this is a very common plant. I am sure some of you must have even studied at the undergraduate level, called Ipomea head caladana. It is, I think we have taught you actually, it contains resin and it is used actually as a purgative. It is no longer used for that. We have found out actually the igdazone being present in that, and then we generated technology for the separation of the igdazone from that, and eventually converted into a 15% formulation. Next slide, please. Next slide. Next slide. This is all just this is the commercial batch actually. Next slide, please. Okay, field trial. I must tell you one instance which has happened when I was working on this project actually. My student was working on this project actually of the igdazone, extraction, the isolation of the igdazone. And the extraction was from the seed part of it. And seed also has a oil in it. Steroids are also lipophilic, but this particular steroid is slightly hydrophilic also because it has a 5-hydroxy group. But when we were concentrating it actually, good amount of lipid was interfering in our purity part of it. And we tried all sort of solvent, and students, very fancy. Students are normally fancy. They keep trying different, ideas actually, for sometimes very costly ideas, So they tried all, and ultimately he came to me, sir, nothing is working. We are unable to separate the lipid part of it. So I asked him, what is the problem? So he said, sir, lipid is the one which is posing a problem. I gave him a very simple solution. Whatever your extract is, simply keep it in a fridge. The lipid part will congeal. Okay, because they get solidified when you lower the temperature, like coconut oil. Coconut oil in this season actually, if the temperature goes below 15 degrees, coconut will congeal. and you'll be able to easily separate from the liquid part of it. And that is what the simple action. I just told him actually keep the extract in the fridge, and whatever congealed part is there actually separate by the centrifuge, and we'll get the clear extract, and we'll be able to raise the potency of that, and that is what precisely did. So sometimes some simple ideas work actually without the complicated problems. Next slide, please. So this is the product which we have developed actually. This was the product to be put into a 20 liter water, and that 20 liter water actually is to be sprinkled on 500 kg of mulberry leaf on which insects were thriving, and that has ensured actually uniform development of the silk insect. Next. All right, last molecule, Thumatin, Thaumatococcus daniel, an important plant material, again very expensive. Currently the price of the Thumatin is in the range of 2 lakh to 2.5 lakh rupees per kg. A protein sweetener, 1500 times more sweeter than sugar. It is obtained from a plant called Thaumatococcus daniel, and it is obtained from the fruit part of it. And since it is a protein, you have no option to use any solvent. You cannot use any solvent. You have to use only water, at the most buffered water, but not beyond that. So when you use water for any fruit, you get a lot of carbohydrate being extracted also, and that poses a major problem for the filtration. So was the case here also, that when we extracted, we had huge problem actually of a mucilage. Mucilage was coming along with the protein, and we were unable to separate, and it was a challenge. And we were using almost 1200 liter water for 5 kg batch. That means 5 kg raw material and 1200 liter water. And in that, mucilage was there, and which was posing the problem for the filtration. It was not getting filtered. So what we did, we used chelating agent. Unfortunately, once again, I will not be able to reveal what chelating agent we used it, but we used chelating agent by which mucilage got bound, and we were able to separate actually by the filtration. So initially separation was taken place actually on the haplosuper cell. Later on it was passed by the microfilter, and eventually it was passed to the membrane filter. This particular molecule is 21 kD, 21 kilodalton, and we use 5 kD membrane by which all the small molecules pass through that, where the retentate was containing our Thumatin, and then it was concentrated, and then it was subject to the freezing first, and thereafter the freeze drying. And that is why, since it involves freeze drying, the material is expansive. Next slide, please. This is the entire setup actually what we have undertaken for the 5 kg batch. We used to get around 700 gram of Thumatin from that. Next. Well, this is around 10 kg container in which barely you can fill 600 gram of the material. So that is the density of the product. Next. All right. So this is an important slide actually from those into the field. Whatever I have shown so far actually looks very interesting and looks very handsome. That every time I'm getting the product, and quite a few of them are expensive. But yes, the entire journey was very, I would not call frustrating, because I never got frustrated. Though many times the product don't get it, but I was determined actually to pursue my line. But what you need actually for this particular work, a mindset. First you have to make up your mind, yes, I would like to get into this particular field. That is most important, because that is the first and foremost important requirement, that you must make up your mind that yes, I would like to get into this field. Afterwards, facilities, many times I have seen faculty member or even student complaining the faculty. Today most of my extraction work actually I am doing with a very minimal facilities. I use only 10 liter RB or 5 liter RB, one heating mantle and some solvent. Okay, most of my fractionation is with the solvent. So I use many solvent rather than chromatography. So most of my extraction isolation work actually is more by the fractionating with the different solvent. So facilities, you need some minimal facility, but you don't need jazzy facilities. I don't think you need very specialized, supercritical extraction. If you talk about it, I have access to all sort of extraction process today. But I do not use any of those methods. I use conventional method for the extraction isolation. Only thing that you need to look at the molecule first. What is the molecule? Look at the properties of the molecule. Once you understand the properties of the molecule, then maybe you can refer some earlier work actually, and then make up your mind. Okay, this is what the work is available, and this is the molecule demands, and accordingly undertake the extraction process. Identification, yes, is a challenge actually, especially when you deal with the new molecule. But known molecule, enough information is available in the form of the literature which you can match with it, and you need not have actually exhaustive literature for that. But for the new molecule, yes, you need. Unfortunately, in India, we do not have many people who can read spectra of natural product. I'm making this statement. unfortunately, we do not have many people who can read spectra. We have many people who can read spectra of the expected product. In chemistry, expected product is known because your reagent are known, what kind of reaction you are undertaking, that is known. Expected products are also known, expected impurities are also known. And that is why you have a people who can read spectra of the expected product. In natural product, there is nothing like expected. Everything is unexpected. Okay, so that is why we do not have many people who can read natural product spectra. So be careful, those who want to get into the identification of the new natural product. Time consuming purification. Purification is a process, is a major problem actually. I remember when I first separated forskolin, I don't think the kind of patients I have, you will have it. 50 times I did actually the processing, 50 times. In one day I used to run almost 25 experiments I used to do actually, and 50 times I used the same thing actually, and at the end of the 50th time, I could get the white powder from the black tarry starting material. So you need good amount of patience, purification, and that is why purification, at every purification step there is a losses, and that is why natural products are very expensive. It is not like that 5% extra is available in 5,000 rupees per kg, so 100% will be available in 50,000 rupees. No, it doesn't go like that. If the 5% is 5,000 rupees, 100% will be maybe around 20 lakh rupees. So this is how, because at every step there will be losses. Time consuming, frustration is a part of it, but at the end it is rewarding also. At the end it is rewarding. Today I have many molecules which are much more costlier than the gold. That I can tell you. Okay, I have a molecule which I am selling it actually at 2,000 rupees for 20 milligrams. So you can imagine now, calculate what is the price of that. Okay, and I have more than a gram. Vasicin today, I have more than a gram isolated from Adatra vesica. Okay, so frustration, yes, when you do, you get frustration, but once you know, okay, I mean, you're going to get a product, I don't think there's a scope for the frustration, you enjoy. And every time when we do work, actually, you come to know some new thing, and that becomes useful for the subsequent thing. Yes, what you need actually a good determination. Good determination, that means you need to confine to that and pursue relentlessly, most important. Then only you will get the good fruit out of it. Never give it up. Good thing always takes time. So have patience, and I'm sure actually the outcome will be highly rewarding. Thank you very much. Next slide, please. Next slide. I'll just take another couple of minutes. This is what the phytochemicals which are generated in the lab. I'll quickly go through that. Next. These are some of the technology which are transferred to the industry. Next. These are some of the monographs we have made for the ICMR. Our lab has contributed 60 monographs for the ICMR, and these are the volumes in which it is published. Next. These are some of the products, which of course I don't enjoy, but some client comes and we develop for the clients. Next. All right. So effective development of the technology for the extraction and the isolation of the phytochemicals will be highly rewarding. Not necessarily, sometimes you may not get taker in the pharma, but other field they are taker. As I told you, Lawson, I have worked for the cosmetic industry, not for the pharma industry. Next slide. All right, let me just take opportunity to thank Dayanand College of Pharmacy, its management, principal, faculty member, and all the audience which is sitting very patiently and listening to me. Thank you very much.
Thank you, sir. Thank you very much.
Thank you.
So it's a really wonderful session we all have attended today. In line with today's what we can say theme of this international conference, drug discovery and the development. Sir has taken a very appropriate topic, which is very important part for drug discovery and the development. And sir has started with the journey on the phytochemicals, how these phytochemicals are important in our daily life, as well as for the pharmaceuticals, for the food industry, for the nutraceuticals, as well as for our different type of the activities which we are getting from the synthetic one. So in brief, I will say that sir has given this splendid lecture starting with the journey on the phytochemicals. Sir has given a brief idea about the herbals and the botanical at glance, which includes the different roles of these herbals, like the lubricant in the perfume industry, in the natural dyes, even in alcohol also, sir has especially
I'm
explained
looking.
how
It's
it
okay.
is useful in
I see.
different type of the food industry as well as in the pharmaceutical industry. Followed by, sir has also explained very important thing, that is the type of the metabolites. Because if you see this type of the herbals, they have the secondary metabolites like the flavonols and other ones. They are playing very important role because they are having a very important therapeutic activity also. So in connection with that, sir has taken several type of the case study also. This case study includes the different type of the you can say phytochemicals that sir has taken into the consideration during their research work. I will highlight some of the case studies which are sir has explained regarding around 13 case studies they sir has explained, including the caffeine, ambelin, piperine, then leucilon, then mangitonin, aloe, ursulin, and karanja. And from this, Lawson technology sir has transferred to the Godrej industry. So I am requesting that all the participants give the very you can say big clap to sir, because
Thank
a
you.
very important product sir has developed and it is transferred to the Godrej, which is we are using now. And sir has also given the contribution in one of the major product which is known as the Khela, and which is also recognized by the Wikipedia. So it is not a small thing, it is very big thing, and lots of efforts required for such type of the work. And sir has explained in a very simple and very scientific language, so that everyone can get understand how the development of this herbal is taking place, and how these herbals we are using for the synthetic purpose. Like sir has taken the example of quinine, cinchonin, cinchonidine, and their other constituents, and how the important, whatever you can say, the core structure, now the scientists are using for the development of the different type of the synthetic product also. So what some of the synthetic products which we are using today for the different type of the disease and the different type of the disorders, this is possible only because of the discovery of the herbal product and the isolation of the active constituent, or which we are calling as a phytoconstituent from it. So really, sir, I am very much thankful to you
Thank you,
for
sir.
delivering such a wonderful talk. I think everyone have now clear about how these herbal and their phytoconstituents are playing very important role in drug discovery and the development. So thank you very much on behalf of the organizing committee, on behalf of the participant. I am really thankful
Thank you,
to
sir.
Ladda sir for giving insight about the herbal and the phytoconstituents. So thank you very much, sir.
Thank you. If anybody has any question,
Now the session is open for the question answer. If you have any query, I think sir has explained in very simple language. So from my side, I think there is no question from audience, because sir has explained in very simple language with the different examples also how these herbal are you can say we can although in the last part sir has given one important quote: never give up. Good things always take time. Okay? So, and it is applicable in our daily life also. Suppose if you want to achieve something, it takes some time, because one phrase is there, like the Rome cannot build in one night.
day.
Okay? It takes years for development of anything. So, sir has also put their whole life in the herbal industry, phytoconstituent separation, isolation, extraction, purification, and the recrystallization. So it is not a very, you can say, normal process. It is very tough process actually. So that's why at the end, sir has mentioned that we required the mindset. We required, definitely mindset is very important. And second part is the facility for doing all this research activity. Then we required the knowledge about the extraction process, which solvent we have to use, whether we go for the water, we go for the alcohol, or we go for the combination of water alcohol, or we can go for the non-aqueous solvent. So for that, again, we required the basic knowledge about the extraction process. Then identification, purification, and all this required the time consuming. Even we have seen during our PhD work, during our M.Pharm work, we have to spend hours and hours for getting the extract, because see, after the extraction, another important process is the isolation of the active constituents. It requires sometime week, sometime months also, even sometime years also required, because in that case we have to identify the perfect solvent and the perfect procedure which is applicable for the isolation of that particular active ingredients. And definitely this is the frustration you can say sometime we are getting, but at the end sir has mentioned never give up, because the good things always required some time. Okay, so with that I request all the participants, if you have any question, if you have any query, you can ask, please. Yes.
Hello.
Yeah.
Hello.
Yeah.
Sir, on the behalf of students, as there are students from the diploma, degree and PG, so what is the scope to do the work at the college level for the phytochemicals? On which phytochemicals student can work at the laboratory level, at the college level easily? So can you please tell some guidance to our students about that? On which phytochemicals they can work on the laboratory?
No, well, when it comes to the scope part of it, tremendous. See, if you have to buy Vitaferin from a US-based company, is it not insulting for a country? Yes, there are more than 2,000 pharmacy colleges in the country, and still we are buying Vitaferin A, which is from Indian plant and from the US-based company. And that speaks about the volume of the scope which is having it. Okay? We must develop method here, isolate it here, and make available to our own audience. So likewise, many compounds which are there, in fact, I started my journey from precisely from that many phytochemical which we are buying from the Sigma, of which many of them are very expensive. So I said, why not I make it available at the affordable cost? Like ursolic acid, I'm making it available at very low rate. The reason, it need not be 100% pure. You can have 95%, 98% pure, but at least you are making it available at the affordable cost so that further journey can take place. If phytochemicals are not there, I don't think you can think about the nanoparticle tomorrow. So first, what is requirement actually is the phytochemical made available actually in a affordable form. Then only further work can grow. At the institute level and the undergraduate level, see, individually I feel actually it will be too difficult. But if people join together, I started all alone. I also made an effort actually whether some people can join me. I failed in that, I must tell you. I started effort in 1998, but nobody gave me a helping hand. So I started, okay, let's go alone, akela chalo. But today, I think certain things can be achieved actually by joining together. One individual may have difficulty, but if you have collectively, if you can do something, some project, I think there is a scope. According to me, I think extraction isolation one can take. I am from Bombay, so I talk normally in 1 BHK, 2 BHK. Okay? So I think one can undertake this extraction in 1 BHK. Extraction isolation. It is possible. What you need actually one column, that's it, extract and one column. You can come out with a good compound. You need to have a good patient, that's it. And whatever compound you isolate, establish identity, and I can tell you, any compound today can be sold, any compound, because world over people are looking for a newer compound to be undertaken further work. And work is in n number of directions, not necessarily only as a medicine. It can go in maybe dyes. If the color compound is there, it can go in dyes. So a lot of coumarins today are used in the fluorescent dye. A lot of coumarins are used as a fluorescent dye. Okay? So likewise, any compound you make it available, there are takers, that way I can tell you. There are takers. So when it comes to extraction isolation, undergraduate would be a slightly difficult. Though I have published one book actually for the undergraduate just to get a stint out of it, just to get experience. But postgraduate, definitely I feel actually the entire India should work on the indigenous plant first, make it available all the phytochemicals which are there, like picrocide. Where is the picrocide today available? Nobody is dealing with that. Picrocide is so expensive, which is obtained from Indian plant, Picroza crua. Gymnema genin not available. Gymnema sylvester, a plant which is growing in Maharashtra. Nobody is working and isolating Gymnema genin from that. So then a number of plants are there actually on which serious work need to be done. And maybe, if not alone, maybe some people can join together and come out and anything. And I am open now here actually, you give me any phytochemical of this kind, I am ready to buy. Whatever cost you tell me. Because I have a client actually who can buy from me. Okay? Any phytochemical, Gymnema, genin, vitaferin, satavarin, I myself is working on that. Next 6 months I'll be making it available, all these chemicals. But you take any chemical, not obvious, but chemical which is difficult, like vitexin from the Vitex nirgundi. Vitexin, it contains vitexin actually. Very expensive. In fact, it costs some 15,000 rupees for 5 milligram. So imagine the cost of it. Input, yes. As I told you, these constituents are present in very low concentration. You need a good skilled hand. So first develop skill, but it's not difficult, I must tell you. This field is not difficult. What you need is a good patience and good devotion.
Sir, one more problem is facing with the young farm PG students, that they are dealing with the phytochemical, they are doing the extraction and the isolation, but when they are going to analysis, the complex spectra are there. They are not enough, they are getting problems to isolate the compound, purification problem. So can you tell me something about that?
No, purification problem is, see, in my natural product always, because if you look at the biosynthetic part of it, it is not like synthetic that you take 2 molecules and 1 molecule gets formed, nothing of that kind. It is the very systematic process by which these molecules are formed. For example, any phenylpropanol you take it actually, it starts on erythrophos 4-phosphate, the phosphoenol pyruvate, then shikimic acid, quinic acid, shikimic acid, corismic acid, prephenic acid, phenylalanine. So all these molecules are also going to be there in your extract. So definitely isolation is difficult but not impossible. It is difficult but not impossible. You need to think, get into the subject matter. I always look at, in fact, if you come to my lab, I have a Merck index. Anything when we start, I first look at the structure. Whole night I think about it actually, what kind of structure, what molecule, what functional group I can tamper with it, I can make use of that. So once you do that, maybe few case studies you will have difficulty, but later on I don't think you need to come know, you need to even talk about or find out actually, then you will come to know. If you handle some 3-4 varied molecule from the different field, probably think, today you tell me any flavonoid and I can undertake extraction isolation. Okay, so it is possible. So maybe some time you will have to invest actually in knowing about the molecule, about its properties, the composition of the plant material from which you are trying to isolate it actually. So all those things will influence. But first thing, another major mistake which most of the student and the faculty does actually, they start with only 1 or 2 kg. That is the biggest mistake what they do it. You must start with at least 10 kg material, most important. Then only you will get some workable quantity of the extract to take it forward. If you start with 500 kg in 1 kg, I can tell you your entire effort will go waste because nothing you are going to get it. So be very careful if you are undertaking extraction isolation, subject not less than 5 kg, preferably 10 kg of the material. Then only you will get, because in the beginning you don't have a skilled hand. So definitely handling is not very careful. You will have a lot of losses. And another important thing which I take care actually, I do not throw anything. Whenever I undertake this activity, I do not throw everything in the lab. You will find some 10 trays are occupied by me, because I always believe that if it is not here, it will be somewhere. So I do not discard anything unless I get that molecule isolated. It is like this. So that is another important requirement. So don't get unnecessarily frustrated and discard immediately because your molecule has to be there somewhere. Okay? All right. I think this is what one can. Yes, sir.
Good evening, sir.
Good evening, sir.
My question is, why cultivation of medicinal and aromatic plants is not gathering movement in India? What are the possible problems they are facing?
Okay. Yeah. Partially it has gained. I won't say totally, I do not agree that it has not gained. Today aloe vera is available readily without any problem. Okay. In fact, last summer actually I had a tremendous problem actually. I wanted an aloe vera leaf, but we were not getting it. Okay, that was the problem. At the same time, there is other situation also. There are many aloe vera leaf available, there are no takers. So this kind of situation will arise. See, in agriculture, this is the major problem every time. Sometimes you'll have a shortage and sometimes you'll have a excess supply. It happens every time. Okay. Now, NMPB is doing that. National Medicinal Plant Board actually, they are trying to encourage farmers to get into the cultivation. Initially, they started providing some subsidy also, 25,000 rupees per acre. They were giving it actually to encourage farmers. I don't know what is the current status. Tomorrow I am meeting Mukat. So, Dr. Mukat, I am meeting tomorrow, so I will find out whether they are still giving that. But that was the thing which was undertaken, which was given actually for encouraging people. And there are certain, I have seen some success stories actually, like in Maharashtra, Akola, they have started, and today good amount of cultivation is there of the long paper. Good amount of cultivation. Okay. If you go to Buldana district, good amount of cultivation is there actually of Safed Musli, Chlorphatum burivilanum. Good amount of cultivation.
Okay, sir. Myself, I have prepared geranium oil by steam distillation, but I could not get marketing people because they are not interested in dealing with the farmers, sir. What is the problem?
No, okay, I mean, all right, I got your point. This is more to do actually with the marketing, sir. Yeah. Okay? Sometimes you need some business acumen also. Okay, besides being scientific, you also need to be a business acumen. First of all, when you get into any field, you must find out, do some survey, what is the requirement. I did that actually, as I told you, when I got into the phytochemical, I found out actually it's pretty expensive and nobody is doing it, so I started.
Okay, thank you, sir.
Okay, geranium oil, there is a problem actually because many growers, they have grown actually and there are no takers. And cost of cultivation, because the yield is less, that is why cost of cultivation is more. That is another problem. See, sometimes it is also important that you must take in the natural habitat. You try to grow something here which is not indigenous here, then you face a problem because you don't get the enough yield. And many a time the agriculture university must come forward and they should educate people actually, do and don't, must, which by and large they fail it actually. And people, they start on their own and then they suffer because they get influenced by someone who shows them very rosy picture and then they get into that. But otherwise people should I feel one should seek actually appropriate authorities, consultation. Yeah.
Yes, any other participant? Yes, last.
Any more?
Yes, one.
Please come forward.
Good afternoon, sir.
Good afternoon, ma'am.
I'm Dhanashri Gadekar. Sir, I have completed my M.Pharm from School of Pharmacy, Swami Ramananda Tirtha Marathwada University, Nanded. Sir, I have one problem that during my M.Pharm, I have come up with that problem that I was working on a herbal plant formulation and no previous data was available on that plant, and I was facing that I have read somewhere in the literature, Ayurvedic literature, that the leaves paste of that plant was having an wound healing property. But at that time, I was unable to decide that what might be the solvent that I can choose for the isolation or the extraction of that plant leaves. Sir, for the first time, if anyone is having the extract of herbal formulation, which is having no previous data available, then what might be the solvent one choose for the extraction?
Okay, any other? Okay, fine. I got your point. First of all, there is nothing like unknown plant material. It may be unknown to you.
Yes, sir. I have
okay.
surveyed on the
So
literature.
that is what you must do, a very exhaustive literature search to find out. Secondly, we have also taught you actually chemotaxonomical classification.
Yes.
Okay. Now, for example, if you are, let's say you have come across a plant which belongs to the Rutaceae family. Let's assume for a time being, Rutaceae family. Now, Rutaceae family, in general, all the members of the family do contain some volatile oil.
Yes.
So this is what chemotaxonomical classification will give you some idea. Okay, that is another thing. Secondly, when we talk about phytochemicals, there are umpteen number of phytochemicals, but there are very few classes. At the most, there are 15 classes of the phytochemicals, and number of phytochemicals are more. So what you need to evaluate only if the 15 classes, whether they're there. And that too is very systematic. There are some water soluble, some oil soluble, or pet ether soluble, and some semi-polar. So I don't think you need to have a tremendous amount of work to be undertaken actually. As regard to the pharmacology is concerned, I think by this time also many molecules are found to, for example, flavonoids. Flavonoids actually are universal enzyme inhibitor. Okay, so when you talk about NSAID, you know what is happening actually in the pain, that it is prostaglandins. Okay, so if you have prostaglandins, definitely all the flavonoids, they will act on a COX-2 inhibitor. They will act as a COX-2 inhibitor. They will not allow actually the prostaglandin to form. So definitely they will be having the action of the pain killing or the anti-inflammatory. So this kind of information you have to only connect it actually. Information is available. You need to connect what kind of molecule is there, and certain molecule you can easily check actually in your compound. First of all, name of the compound, to which family it belongs, that will give you some idea. Secondly, do some preliminary chemical analysis, whether it contains phenolic constituent, steroidal constituent. There are only 15 classes to be judged, not more than that. Make a systematic tabular form, what it contains, which is the predominant in that. Sometimes you may get 2 or 3 constituents, find out which is the predominant in that, and whether you want to take it forward, that predominant one. If you want to take it forward, then everything plan as per that predominant phytochemical. So today it is possible actually that you have enough information available. At the same time, I mean pharmacological action also to agree. Of course, I don't work in pharmacology, but it is very possible actually to at least, I mean, you can have some hypothecation kind of thing, you know, okay, it may have that kind of pharmacological action, okay? So that is possible to draw some conclusion based upon the literature and maybe some preliminary chemical study what you do. Based upon that, I think you will be able to come to some conclusion to take the matter forward. Anything else?
Yes, any other participants?
I'm sorry. Any other question?
Yes, madam, any other question from your side?
No, sir.
Okay.
Thank you. All right. Thank you very much once again.
Thank you, sir. Thank you very much.
I would like to express my gratitude and also thankful towards Dr. K.S. Ladda sir for giving such a knowledgeable and valuable session, and also thankful to Dr. Shailesh Vade sir for giving such a nice briefing regarding this session as a chairperson. Thank you once again to both of you. Thank you so much, sir. Now we are moving towards the next session, third session of this international conference. The next session is online session. The speaker of this session is Dr. Irina Postolikina, Associate Professor, Karaganda University, Republic of Kazakhstan. And the chairperson of this session is Dr. Surendra Gatthani, Professor, School of Pharmacy, Nanded. I request to technical team, please look after any technical requirement for the smoothly conducting the online session. कमिटीने आपल्यासाठी चहाची व्यवस्था केलेली आहे. तर स्टेट आपल्या ऑडिटोरियमच्या बाजूला चहाची व्यवस्था आहे. ज्यांना कोणाला चहा घ्यायचा असेल आपण चहा घेऊन येऊ शकता.
हॅलो चेक हॅलो वायर आलं का हॅलो चेक आला का आवाज हॅलो चेक हॅलो
स्टँड घेते असलं काही बी लावलं का इंटरनॅशनल कॉन्फरन्स आहे अरे आले का ते हां ते हां युरोपियन जर्नल आता कॅमेरा बंद करा हॅलो मॅडम म्यूट करा प्लीज म्यूट इट जॉईन केली त्यांनी सांग काय झालं म्यूट करा आणि कॅमेरा चालू करा लाईव्ह ना कुलकर्णी सर कुलकर्णी सर कुलकर्णी सर सांगता का मॅडम
हॅलो 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 हां डॉक्टर इरिना हॅलो Hello.
Hello.
Yeah, Dr. Reena. It's a tea break. Can we start session after 10 minutes? Is it okay?
Okay.
Huh? Okay.
Okay.
Yeah.
I can start?
10 minutes, 10 minutes.
10 minutes.
10 minutes,
okay.
yeah, okay. Thank you for cooperation, ma'am.
बंद करायचं का बंद करायचं का बंद करायचं का
बाल्कनीमधले जे स्टुडंट आहेत त्यांनी बाल्कनी खाली करायची आणि खाली येऊन बसायचे सगळेजण. चला लवकर.